Alright, today what we have is some examples from your textbook 3A, exercise 3.2. Alright, and the first question that I'm going to go through with you all today is 1C. Okay, for 1C, what we have is x over 5 is lesser than 2. Okay, how do we solve this inequality? Now, there is x over 5, so what we do is we multiply both sides of the inequality by positive 5. So x over 5 times 5. Okay, let me just work it out for you. And 2 times 5. Does the direction of the inequality sign change? In this case, the answer is no, because we have multiplied both sides by a positive number, so there's no change in the direction of the inequality. So I just stick with this. So 5 and 5, it eliminates, and I get x is lesser than 10. That's it. Okay, now we have one more thing to do. The question actually asks for us to represent the answer on a number line. Okay, so first and foremost, let me use a ruler. Let me draw this. This is 10. Okay, x is less than 10. Lesser means that I'm going to go to the left. Right, lesser than. Notice that there's no equal sign there, so x is lesser, it cannot be equal to 10. So I use a white dot to represent this. And then I use my ruler, and I draw, and I say that this is x. Notice that x is lesser than 10. It does not include 10 itself. And that is example 1C. Next example I'm going to go through is 1h. Okay, first now we have 1h. This. Okay, question 1h is 6x plus 7 is greater than or equals to 8x minus 5. Okay, let's start with the numbers first. Plus 7 on this side, so I shall minus 7 from both sides of the inequality. So 6x plus 7 minus 7 can 8x minus 5. What's happening here is I will minus 7 from this side, I minus 7 from the other side. 7 minus 7 becomes 0. So I get 6x is greater than or equals to 8x minus 12. Just like an algebraic equation, what I'm hoping to achieve is to collect all my x terms on the left hand side. So now what I should do is I have to minus 8x, okay, from both sides of my equation. So what I get is 6x minus 8x is greater than 8x minus 8x is no x, and I leave the minus 12 there. What I get is negative 2x is greater than or equals to negative 12. Aha! Now if you notice we have negative 2x here. How do I get rid of negative 2x? Or negative 2 rather. You think for a moment, just like an algebraic equation, what we'll have to do is to divide both sides of the equation by negative 2. In the previous lesson, we have learned that when we multiply or divide both sides of inequality by a negative number, what happens? That's right, we have to change the direction of the inequality sign. So now if I divide both sides of this inequality by negative 2, negative 2x, okay, negative 12, I will divide by negative 2, I divide by negative 2. Division by a negative number leads to a change in the direction of the inequality. Negative 2 divided by negative 2 leaves me with x is lesser than or equals to negative 12 divided by negative 2. Negative and negative gives me positive 6. So now I get x is greater than, oh no, sorry, x is lesser than or equals to 6. Now again, question asks that we draw a number line. So we get 6. Lesser than or equals to. Notice that now we have this or equals to sign there. So first I draw. In this case, back then it was non-inclusive of 10. In this case, it can be equals to 10. So I will color the dot. Okay, the colored dot means that it can be equals to 6 itself. X is lesser than or equals to 6. So if I draw an arrow, and I have represented this inequality on a number line, and x is lesser than or equals to 6.